My dear students, in this video I am going to introduce the integrals of inverse trigonometric functions. Example, derivative of sin inverse x equal to 1 by root of 1 minus x square. It is d by dx of sin inverse x is equal to 1 by root of 1 minus x square. That's we have to prove. See, y equal to sin inverse x. This is our result. D by dx of sin inverse x equal to 1 by root of 1 minus x square. The substitute for y equal to sin inverse x. By definition of inverse trigonometric function, operating sin on both sides, sin y equal to sin of sin inverse is x. Y equal to sin inverse of x, operating sin on trigonometric function, sin on both sides, sin of y equal to sin of sin inverse is x. Now again differentiating with respect to x, sin y derivative is cos y into derivative of y is dy by dx. Derivative of sin y is cos y into y derivative dy by dx equal to derivative of x is 1. And you know cos y is root of 1 minus sin square y by trigonometric identity. Cos y equal to root of 1 minus sin square y. So sin y you know x, therefore replace sin square y by x square. Therefore root of 1 minus x square into dy by dx equal to 1. And from the dy by dx equal to, you bring this root of 1 minus x square to the right hand side, it becomes 1 by root of 1 minus x square. And y can be replaced by sin inverse x. D by dx of y is sin inverse x equal to root of 1 by root of 1 minus x square. Y can be replaced. That's all good result. So similarly, second result is d by dx of cos inverse x equal to minus 1 by root of 1 minus x square. Minus 1 by root of 1 minus x square. Third one, d by dx of, derivative of, from this I am going to do integration, is it not? One more thing. From this result, from this integral of 1 by root of 1 minus x square equal to dx. 1 by root of 1 minus x square dx equal to sin inverse x. So reciprocal function. Derivative of sin inverse x is 1 by root of 1 minus x square. Integral of 1 by root of 1 minus x square dx is sin inverse x. This is our first result. Integral of inverse trigonometric function. That is integral 1 by root of 1 minus x square dx equal to sin inverse x. Okay? And similarly, the second result, integral of minus 1 by root of 1 minus x square dx equal to cos inverse x. Third one is integral 1 by x into root of x square minus 1 dx equal to secant inverse x. Integral 1 by x into root of x square minus 1 is secant inverse x. Fourth one, integral minus 1 by x into root of x square minus 1 dx is cosecant inverse x. And fifth one is integral 1 by 1 plus x square dx is tan inverse x. From the derivative of tan inverse x is 1 by 1 plus x square, you know. So integral of 1 by 1 plus x square dx is tan inverse x. Similarly, integral minus 1 by 1 plus x square dx equal to cot inverse x. These are the 6 integration results of inverse trigonometric function, for inverse trigonometric function. Integral minus 1 by root of 1 plus x square dx is cot inverse x. Now using these results, we are going to solve some problems now. Okay? Now, using our previous results, I am going to integrate this problem. Evaluate integral 1 by root of 1 minus 4x whole square dx. You replace 4x by t. Derivative of t, dt is derivative constant 4. Derivative of x is 1 into dx. dt by dx is 4. So, you will get 4 into dx. That dx on bringing right hand side, it becomes the numerator. 4 derivative of x is 1 into dx. Okay, this I can replace by dt by 4 equal to dx. So in this integral, you replace dx by dt by 4 and integral 1 by root of 1 minus 4x the whole square dx equal to ds can be replaced by dt by 4 and that 4 can be taken out and 1 by root of 1 minus t square because t, 4x is t. So this has become 1 by root of 1 minus t square, dx is dt by 4, that 4 can be taken out of the integral. You know this is equal to 1 by 4 into integral 1 by root of 1 minus t square is sin inverse t, you know, and t can be replaced by 4x. So you can get the answer 1 by 4 to sin inverse of 4x plus c. That's the answer. Okay? Integrating constant c. T can be replaced by 4x again. So it is simple. Integral 1 by root of 1 minus x square is sin inverse x square. But 4x coefficient should be divided by the answer. So this coefficient of x is divided by 4. In the answer step, you will get 1 by 4 into sin inverse 4x. That's all the answer. Similarly, one more example. Evaluate the integral 1 by root of 1 minus 81x square dx. This is minus 1 by root of 1 minus 81x square dx. You can take that minus outside integral 1 by root of 1 minus 81 can be expressed as 9x whole square dx. 9 square is 81x square. So 81x square can be expressed as 9x whole square. As in the case of this problem, you replace 9x by t and 1 by 9. This becomes minus sin 1 by 9. Integral 1 by root of 1 minus t square is sin inverse, minus sign is there, therefore cos inverse of t is 9x plus c. So minus 1 by 9 into this, sign will not be, you will not get the sign. If you get minus sign, it is sin inverse. So minus sign, if you introduce the answer, you will get cos inverse. Or otherwise minus 1 by 9 into sin inverse 9x plus c or just 1 by 9 cos inverse 9x plus c. You can read it, both answers are correct. Okay. So because minus 1 by root of 1 minus square is cos inverse x. Therefore 1 by 9 into cos inverse of 9x. And the t can be replaced by 9x. Okay, this is our problem. And one more, and another example, integral 1 by 1 plus 4x the whole square or 16x or 25x dx. Integral 1 by 1 plus 20 by x square dx. This can be expressed as integral 1 by 1 plus 25 is 5x the whole square dx. So it is of the form integral 1 by 1 plus x square. So integral 1 by 1 plus x square is tan inverse x, you know. If you replace 5x by t, integral 1 by 1 plus t square is tan inverse t, and that 5 can be taken out of the integral, you will get 1 by 5 into tan inverse of t is 5x plus c. Integral 1 by 1 plus x square is tan inverse x. X can be replaced by 5x. So 1 by 5, the coefficient of x, 5 will be divided by the expression. So 1 by 5 into tan inverse of 5x plus c is the result for this problem. Like that, the problems can be evaluated using the direct results of inverse trigonometric functions. So this is 5x can be replaced by t. If this is 1 by 5 into tan inverse t, t can be 5x. That's all. Okay. Next, we will evaluate this problem. Integrate 6 by 1 plus 3x plus 2 the whole square minus 12 by root of 1 minus 3 minus 4x whole square dx. two expressions are there. In this problem, we have two expressions, therefore we have split this integral into two integrals. That is, you can take 6 outside of the integral, 1 by 1 plus 3x plus 2 whole square dx, minus you can take 12 outside integral 1 by 1 minus 3 minus 4x the whole square, square root of 1 minus 3 minus 4x whole square dx. So in this integral you can replace 3x plus 2 by t. Therefore you will get integral 1 by 1 plus t square dx minus 12 into integral 1 by root of 1 minus u square dx. Here t is 3x plus 2. First integral you can substitute 3x plus 2 by t. The second integral you substitute 3 minus 4x by u. Okay, so this is, if you substitute this t, it will become dt. And if you substitute by u, this dx becomes du. Simplest, because du is minus 4 dx. Du is minus 4 dx. So dx can be replaced by minus 3. From this du equal to minus 4 dx. So this is minus 1 by 4 du equal to dx. So dx can be replaced by minus 1 by 4 into du. Therefore you will get minus of minus. So in the second step you will get 6. Similarly, t dt is 3, derivative x is 1, 3 dx. Constant is 0, derivative of constant is 0, therefore the derivative of t is 0, therefore you just get dt by dx equal to 3 only, so 3 dx. And the constant derivative is 0. Similarly, derivative of constant 3 is 0, du by dx is minus 4, so du equal to minus 4 dx. From this you will get into minus 1 by 4 du equal to dx. From this you will get minus 1 by 3 dt equal to dx. So here you will get 1 by dx can be replaced by 1 by dt by 3. Similarly, in this problem, dx can be replaced by minus du by 4. Therefore, du by minus 1, sorry. So you take this 3 by cancelling 6 by 3 in integral 1 by 1 plus t square dt. Similarly, minus of minus, this become minus plus 12 by 4. This minus can be multiplied, divided by minus is plus 12 by 4. Integral 1 by root of 1 minus u square du. Now state results. 1 by 1 plus x, the entire 1 by 1 plus x square is tan inverse x. Therefore this is 6 by 3 is 2. Tan inverse x is t plus 12 by 4 is 3. 1 by root of 1 minus u square is sin inverse u plus c. Single constant can be added. So again replace t by 2 into tan inverse of t is 3x plus 2 plus 3 into tan inverse of u is 3 minus 4x plus c. That's all about the problem. So this integral can be split into two integrals, and the two integrals can be integrated separately by giving two substitutions, and thereby we will get the result by applying inverse trigonometric functions. Okay, that's all about this problem, and I stop my video here, and the next idea will be we will continue in the next video. Thank you.